Okay, let's talk real quick. So I hear a lot of talking about the test. Okay, real quick. The average for the test was not so bad. I mean, I don't know, like 72 or something like that. I mean, that's not terrible. It's not great, but that's really quite in line with like pre-calc average and stuff like that. But there was a weird mix. I mean, a lot of people scored like 40 points. Several people scored much higher than they usually do, and several people scored train wreck disaster, like 40 points lower than their average last semester. And I think part of that might have been the snow day. People just weren't ready. Definitely part of it was literally only like 4 of you did the online virtual day assignment that I sent you. I mean, that was excellent preparation to do for the test, and literally like 4 people did it. And so I don't really know what to do about that. So here's the deal. I don't have the test with me right now. I just forgot them at home. After today, if you want to see it, that's no problem. I might even bring it in on Friday, although I know we have an issue with Friday about people being here. We'll talk about that in just a minute. But in the meantime, you guys have seen I shared with you a document and then made a bad choice about, hold on just a second here, about how I sent it to you. Hold on. Alright, so there is a project, just like one of the tests in the first semester, where a whole bunch of folks had made, okay, there we go. Well, I think people hadn't been prepared correctly for the test. We just did a project. That was that one about rockets that time. So rather than having you guys redo parts of the test or whatever, we're going to have you do this little project. If you want points back, it's worth up to 20 points added to your grade. I won't let anybody's grades go over 100, but that's okay. It is absolutely 100%, I am not kidding, it is absolutely not group work, okay, any more than your test was. If it ever got back to you, like you worked on it as a group or whatever, that would be a big, big trouble. But it is a project, and you can get up to 20 points added to your grade, which is 2 freaking letter grades. I think that's more than generous. And it is a project, in this case, it's about bungee jumping. Okay? Bungee jumping has all kinds of stuff about angles and oscillations and stuff like that. And you're basically building a set of graphs in Desmos that depict how the, like the position of the bungee jumper at different times and so on. There's actually a videotape about what video here about what we're doing. All the information you need for the problem is right here in this, and I walk you through it step by step. I even highlight, go to these pages in your book. The answer is literally there as to how to do the equation. You know, look for things like blue boxes with yellow highlighting, and you should be able to get all these points, okay? So this is due on here, I think it says Tuesday, right? I'm not sure what I put on there. February 2nd, the 12th at noon, whatever. Okay. Alright. So, yeah, I don't really know what happened. Like I said, we ended up with almost exactly the same average as we normally have, but man, the test scores were totally scrambled. Plenty of people who normally score well above average ended up way below. Several people who normally score well below average ended up way above. I don't know what happened. My guess is it was just the snow day. Yeah, Rose.
So it says if you complete the project on time. Are you saying like if we get the problems right or if we just do it? Because what if I don't get it right?
Here's the deal.
Yeah,
Most of the problems key around you correctly modeling this bungee jumper, his position. You know, it's an oscillation, so it has those kind of, you know, it's a periodic equation. It's got, here, where is it right here? You got to get the right values of A, B, C, and D in here. But here's the deal. If you have the wrong values of them, the project, it moves forward. Okay? I mean, like when you do answer the next question about certain angles and stuff like that, I use your numbers. If you got the wrong values of A, B, C, and D, I'll use your numbers. I mean, what would you have gotten for the next problem then? Okay? But, I mean, I literally even give you, well, first off, I'm not going to say it's going to be hard to get them wrong, but I mean, I literally point you to exactly the page as to how to compute the A, the B, the C, and the D. Okay? I don't know exactly how much more I can possibly have given. And then you compute the A, the B, the C, and the D. And if you have them right, this is exactly the graph you get. Okay? You'll know whether you've got it right or not. And it specifically says you can bring it to me and I will help you with that. Okay? But if you have the wrong numbers and you just can't get this graph, this is where the bungee jumper is, and so on this time, I use your answers for what moves forward. Okay? You don't, like you're going to then build another graph like this. I'll use your value, I will make your graph with your values of A, B, C, and D, and make this graph, okay? I'll do it, I'll put the time into that. okay? But the thing was specifically designed as if you weren't able to get the correct values of A, B, and C, and D. I'll use your answers. Make sense? All right. All right. Cool. Yeah, it went to mess, but the business of not doing the online activity, that was odd. Okay. Yes, Ryan.
So did you talk about the online activity in class?
No, I texted you several times about it and emailed you. Yeah. So that was part of our makeup for the virtual day and all that. So yeah, that was not unclear. All right. We do have something though that isn't entirely clear, and that is we have to sort out who's here on Friday. So let me just pull this up right quick here. I need to know who is, okay, remember, all juniors are required to go on that field trip. Seniors who are going to USI are required to go on the field trip. Seniors who are undecided about where they're going are required to go on the field trip.
Well, I have a follow-up question. What if you were a senior, and I'm not, but what if you were a senior who you were undecided, but you knew you weren't going to USI?
I think that they want you to consider it.
Okay.
Yes. All right, I'm pretty sure that was everything out. So we real quick here need to know who's here and who's at the field trip on Friday. So let's see, Symphony, are you on the field trip or are you here? Your field trip. Cannon, you're a junior, so you're here.
No.
Malia,
No,
no.
juniors have to
Juniors
go.
are going.
Oh yeah, wait a minute, I'm gonna take it. Juniors have to go. Malia, you're going?
Yeah.
All right. Like Brennan, your field trip?
Yep.
All right. How about Aaron? You're here. Ashley's not here today, so I don't know. She's going.
She's going.
She's going? All right. Yes, let's just
She wants to consider.
Yeah, they want maybe. Okay, Rose, what are you doing?
Field trip.
Your field trip. Maddie,
I'm here.
I'm sorry. You're here. Jessica is not here. We don't know.
Wait, ask Maggie.
Do you know? Does anybody know what she's doing?
She's going.
She's going to the field trip. All right. Oops.
You said, what time are you gonna visit?
Macy's not here, but I think she's a junior, so she's going on the field trip. Natalie, you're a junior, so you're going on the field trip. Jacob, you're a junior. Merck, you're a junior. Ryan, what are you doing?
I'm not going.
You're not going on the field trip?
No.
Okay, so you'll be here.
I'll wear
All
a
right.
union t-shirt that day.
Houston's a junior. Latavia's a junior. Brooklyn, what are you doing?
I'm not going.
You're not going, so you're here. And Braden, you're a junior. And Mackenzie, what are you doing?
I'm going.
You are going? Okay. And that's it. Okay, so 1, 2, 3, 4. 4 for sure are here. Okay, here's the deal.
Woo!
Yay!
Just cancel class,
That was my plan.
please.
Here's the deal. We are having class. Okay. Well, the way we're doing it is we are treating it like a, no. We have to treat it like the people who aren't here are just sick. It's like an excused absence. Okay? So you have to make up the work for that day. Okay? So in other words, we're not running it as a virtual day. We're not handling it as a canceled school day. We have to run it as a day that you just missed, like you were sick or something like that. Okay? But there is no guidance as to how much material we actually cover.
Okay.
Okay? So here's the deal. We're going to do something on Friday that will involve probably some like further work on what we're doing today. And maybe a little bit of growth into the next thing, but it isn't going to be a huge, like, oh my God, you just missed a huge, we learned a whole bunch of new stuff, or whatever. And then there'll be an assignment with it. It therefore will be something you can miss, and it's not the end of the world, you'll just do it and turn it in a couple days. It won't actually have the, a deadline and stuff, I just don't have it yet. Okay, so that is the plan with that.
I'm sick.
Now,
I'm sick.
there is...
Everyone got malaria.
There's one other thing to sort out. Okay. There is some confusion going on about the second day that we canceled because of snow, Friday. Because your parents have gotten 2 pieces of information that are contradictory. One piece of information that was sent said that it was going to be done as a virtual day. And another piece of information that was sent said, no, we will be open, obviously you'll be open on President's Day. Okay.
So what is it?
Well, we just 2 days. So
Well, my understanding is before they actually figured out that like left hand didn't know what right hand was doing, they already had done things like, book for the cafeterias to be open and all that kind of stuff. So now now we're kind of committed. They pretty much have to have the school open on President's Day. So we are open on President's Day. Okay? Here's the deal though. There is some confusion as to what we're doing on that day. Because the day we missed is a college day, like a Tuesday, Thursday. But that's a Monday. And so...
Wait a minute.
Yes. So obviously this is not a big problem at like the home schools. But it's a big problem here because if we run on a Monday and we teach Monday classes, the problem is that is what you missed. Now you're way ahead on the Monday, especially classes that like English 12, where there's a Monday, Wednesday, and a Tuesday, Thursday section. The Monday, Wednesday section is going to be getting pretty damn far ahead of the other section, right? On the other hand, if we run the Tuesday classes on Monday, the problem is there's people in IB Tech classes that wouldn't be able to go to their Monday classes. We have not yet decided. This is still a head scratcher for Wendy and Meryl and stuff like that. Yeah.
Why don't you just say that we're here and you do a virtual assignment?
Yes. Well, we're actually thinking about it as a possibility too. But we have to have you here. The problem is you have to physically be here because it's the day that you're accountable.
Check that day, like you said.
Yeah.
College class.
And so they are still trying to figure out. They're looking through the fine print and the instructions and stuff like that, so that we're not violating EBSE policy. The point is, plan to be here on President's Day. Like, don't pick up a shift at work or something like that because it's a holiday. Okay. Now, I'm pretty sure you wouldn't have anyway because I believe IB Tech is not closed for President's Day, and so you probably weren't going to pick up a shift anyway or something like that. But if you were planning on like not being here on President's Day because it said it was on there, sounds and you're like, hey, wait, my parents got a post that said, an email that said that it was a virtual day. The problem is they also got one that said it was a President's Day thing. And so, yeah, I'm sure they're totally confused. Plan to be here. We are not yet 100% certain whether that will be on Monday, Wednesday day or a Tuesday, Thursday. What we're going to do is we're going to go through everybody's schedule and see how many people would mess up. If we ran a Tuesday day on Monday, how many people would that mess up?
When will they know what it is?
Probably later today. Yes. And I think the most likely thing is we'll probably just run a Monday as a Monday and we'll put the Monday sections together. Because it's early in winter, for all we know, there'll be another snow day later.
So we're still going to do a virtual assignment for the day that
Summer registration.
Which, you mean the snow day or whatever? Okay, the snow day we had, we could go yet today. That is, half of it was an online activity that you did, and half of it is that thing that is due in a couple days where you're learning. Remember I said to you the Khan Academy videos, and it is that stuff? Right? That's the other half of it. I sent you guys a link to that. Would you want another one? Yeah. The Khan Academy thing is only 20 minutes long. Okay?
You just have to watch the video.
30 minutes. He tells me it's 30. Anyway, so it's a half the thing, and then the other half of the thing is that online experience. Okay? I'll send you an email if clarifying that would help. I'll send you an email clarifying all that. Yeah.
When do we have to have all that done?
I forget what the date I sent you guys.
Was it the 11th?
It's Monday, I think. Yeah. Yeah. So it's just a little Khan Academy thing. It has a, you know how Khan Academy crap is. It's like 3-minute little pieces, and then you move to the next one, you move to the next one. It's like 8 little 3-minute pieces.
It's like your online lectures for science.
I know. It's almost like I modeled that. Anyway, I appreciate the fact that this is all kind of confusing and messed up in these snow days and the miscommunications about them. But the main thing is we'll get everybody on track and we'll get all this done, and by next week we'll all be back on the right page and so on. And some of the classes will actually be a little ahead. Not this one, but some of the other ones. All right. Moving forward, we're going to be doing more things now with the trig functions. We're going to be using the trig functions to solve different kinds of problems. I guess I can get rid of the screen here now. Oh, one last thing I was going to tell you about. You probably saw you had an invitation in your email to do Google Classroom for this class. We'll do that from here on forward. As they're deprecating, you guys know it's learning's going away. And as they're deprecating it, things are breaking and all that crap. We're just screwing. There's no point in posting content. It's learning. It's like going down and all that kind of crap. So we'll just move over from here on out. It's on Google Classroom.
Is that every class that's just going into?
Well, we are. I don't know. I think Mrs. Russellberg and Mrs. Sharp are going to fight it out to the end of the semester. But yeah, as different features like are expiring and stuff like that.
What's the classroom group?
What? You don't need a code, I don't think. I sent you an email.
I don't have the email.
You didn't get the email?
If I did, I didn't
like it.
I'll get it for you then. I don't have to go off the top of my head. Really? You didn't get my email here?
Well, maybe if you didn't, why did you delete his email?
This is awful. It's awful and it's expensive.
Well, no, it wouldn't be an email.
It never really worked. It breaks so often.
Aren't you glad that you're not a
Yeah, I don't have it either, and I don't delete any.
Yeah.
I don't.
All right. So it could be. Did anybody get the code, the thing to join Google Classroom? I did it last night about 10 o'clock.
On my.
I wonder if I did.
Yeah, you probably did.
Wow, that's pretty neat.
Okay.
I got mine.
So I just did a separate.
You did? Thank you.
But don't worry about these, I don't have it.
The hooligans.
Yeah, I got it.
So you
Okay.
only send it to the seniors.
That's what I tried to do, but it won't take my little.
It's possible.
That's what it sounds like.
Well, I just cut and pasted the class list in. That's interesting. Okay.
So I have to give them.
All right. Well, I can send it again if I didn't hear back from you. I can send you the link if I can this time. All right. Anyway, we'll get it set up. The point is, we got to move over to Google Classroom, and that's okay. It's kind of cleaner and easier. There's less craziness going on in it. We'll just move over there. It'll be better. Okay. All right. So we're moving into chapter 5 today, and we're just going to be starting into more things you can do with these trig functions. And if you take your book and go open to page 350, there's our old friend, blue box with yellow highlighting, that has a mess of what it's calling the trig identities. Fundamental trig identities. Uh, 350. And page 350 has all these trig rules, many of which you already knew. Like secant is 1 over cosine, and sine is 1 over cosecant, and all these kinds of things. Those are the so-called reciprocal identities. And a few of them are the so-called quotient identities that shows how like tangent is related to sine and cosine, or how cotangent is related to sine and cosine. And those you already knew. You knew those. You seem to actually know those before you even came to my class. I think you learned them in Mrs. Webster's. And then there's these weird ways of writing the Pythagorean theorem, using sines and cosines and tangents and stuff like that, of which only the first one I can never remember. The other ones I always have to look up. You're going to find a theme in this in just a little bit. And then they start getting kind of weird. There's the cofunction identities and the even-odd identities. The cofunction ones are ways of expressing how like one, like some of these functions are just each other shifted horizontally. Like sine and cosine are related by just shifting left and right from each other. Or tangent and cotangent are related that kind of way, and so on. But here's the deal. All of these things in the blue box with the yellow highlighting are in that page inside the front cover of your book. Every single one of them there. And you will always, at the very least, have this page on any kind of test or anything like that. So memorizing those guys, well, that's just not really where you should put your brain cells, right? That's not really the thing. It's more a matter of being able to solve problems that use these things. And if you take a look at this chapter real quick and scan it, you'll see it's only 4 pages after this section. It's only 4 pages. Basically, all we're doing today is more examples of working through these different kinds of functions and the kind of problems we can solve with them here. Like, for example, example 1. You use the value secant of u equals 3 over 2 and tangent of u is greater than 0 to find all 6 trig functions. All right. So it says secant of u is equal to negative 3/2. Yeah. And notice it tells you this weird thing that tangent of u is greater than 0. Yeah. You're going to try, you need this information to solve this problem here. And it says find the 6 trig identities. So we're trying to build up here, well then what is the sine of u? What is the cosine of u? The tangent of u? Cotangent of u? Secant of u, hey, we got that one already. Let's go ahead and put it in. And cosecant of u. Okay. All of these kind of problems involve, using those different identities and solving for them. All right, if you have secant, secant is very closely related to Cosine. Cosine and secant are just 1 over each other. So if we know secant, we already know cosine. So alright, so since cosine and secant are just 1 over each other, that one's pretty straightforward. We got that one already. Alright. Now, pretty much anytime you've got cosine, you can get at least a step closer to sine, because we know this business of sine squared plus cosine squared equals 1. That's one of the ways of writing the Pythagorean theorem, except it's written weird. I hate this notation. I understand why they do it, but sine squared theta means like sine of theta times sine of theta. I know with that 2 being in there, it looks weird. It's as if you wrote it, like that would be the same thing. You took the sine of theta and then you squared that. Same with like cosine. Again, another way to write this would have been like this. I understand for historical reasons why they do it, but it's dumb. Well, it's just hard to learn. Yes? Oh, it has to do with the fact that there's a whole mess of these kinds of functions, and they also, if they wrote it like this, how long would it take before somebody got lazy and didn't put the parentheses there, and wrote it like this? But then what does this mean? This is ambiguous. Because would that mean sine, does that mean like sine of theta squared? Or does that mean the sine of theta and then the whole damn thing squared? There's sort of a, well crap, which way does it mean? Right? So when they write it this way, with the little 2 out here, it can only mean one thing. But isn't it a pain in the butt? It's a pain in the butt. Alright. Well, okay, we could use this form. We've got 2/3. So, sine squared plus cosine squared equals 1. Sine squared plus negative 2/3 squared equals 1. So let's see, sine squared theta equals 1 minus 4/9 equals 5/9. Am I on the right page here so far? So far so good? Yeah. Alright. So that means sine is the square root of this, so it's the square root of 5 over 3. But here's the deal, it's actually plus or minus. Because both minus square root of 5 over 3 and square root of 5 over 3 would work. I'm going to put it up there for now, but that's going to have to be solved. We have to figure this one out. Which one do we mean? Well, wait a minute. The tangent... Let's draw a unit circle here. Hold on. Where am I talking about? We know the cosine is negative 2/3. So the x value here is negative 2/3. So like it's either this place or this place on the circle. And the sine is, well, it could either be positive or negative. So the question is, do we mean this one over here in quadrant 2, or do we mean this one over here in quadrant 3? Well, but we do have some information. We know that the tangent is positive. If the tangent is positive, what is tangent again? It's sine over cosine. I'll get lazy and just write c over it. Alright, so if it's positive, tangent is only positive in 2 parts of the circle. It's either this part or this part. Where either sine and cosine are both positive, or sine and cosine are both negative. So for this to work, apparently we're talking about this one, where the sine is negative. We used our clues that were there in the givens of the problem to narrow it down. Well, okay, now that we've got that, everybody else is solvable, right? I mean, we don't even need to do that right now. Tangent is just sine over cosine, and it's going to take some time to get this all worked out. But it's going to be something like that. And cosecant, which is 1 over sine, is going to be this, which is this. But now we got them all.
No.
Did I do that one wrong?
Cotangent, you don't have space for it.
Oh, I have cotangent. Whatever. 2 over square root of 5, which is 2 square root of 5 over 5. There we go, I missed one. You're right. Alright. But you see what happened here. It wasn't just math. It was a little bit of riddling this thing through. Using the information they gave us to think through what did all this, using putting on our Sherlock Holmes cap, our deerstalker is what that thing is called, and figuring out what can we do with this information. I didn't know what, I could get as far as sine being one of these things, but I wasn't sure which one. But when I made a graph of it, oh, this piece of information made sense. Only this part and this part have tangent that's positive. Oh, okay. So that means that this one had to be negative, so that when I divided them by each other, they were positive again. Okay, made sense. But that's kind of a riddle. Well, we actually did problems quite similar to that in the last chapter. Example 2 does something kind of similar too. It says, simplifying a trig expression. Okay. Well, let's see, what do we got here? We got sine of x, cosine squared of x, minus sine x. Sine x, cosine squared x, minus sine x. If a little parentheses helps, let's put them in there. Alright. So it wants us to simplify this. Alright. Well, I always think that's a little ambiguous. Like, it's a little hard to sort out what exactly, how simple do we mean here. But what I'm noticing, I mean, if this was if we just called this a, and this was b squared minus a, we would know exactly what to do with this. We are survivors of classes like with Mrs. Webster, and we would immediately know, just factor the damn a out, b squared minus 1, and then see what you got. Well, this is exactly the same thing. Instead of a, it's sine x. So I guess we want sine x times the quantity cosine squared x minus 1. Now, whenever I see something that's got a cosine squared or a sine squared, I know from years of doing this kind of stuff that the first thing to think about is that weird form of the Pythagorean theorem. That sine squared plus cosine squared equals one thing. Let me see if that's the right tool. Sine squared of, let's just call it x, plus cosine squared of x equals 1. I pulled those cosine over to the other side. Well, look, sine squared equals 1 minus cosine squared, and that's what I got over here. So this whole thing is just sine squared. I got sine of x times sine squared of x, which is just sine cubed of x. Sine times sine times sine. Yeah.
What's that thing like above, like, what's the exponent for the cosine?
That's a 3, 4 here. That was a 2.
Okay.
Oh, what, my terrible handwriting? Yeah. Emily.
What did you mean, like factoring a?
Well, I mean, like, if this had been written like this, a times b squared minus a, you'd know exactly what to do with it, right? You would have written it, you'd have factored the a out and made it a times the quantity b squared minus 1, right?
Where did that work?
By factoring this, the a out of here.
You divided a by a.
Divided a by a.
But aren't they on the same side?
Yeah, but if you were factoring, here, if you were factoring, look, x, y minus x, wouldn't you just make it x, y minus 1? Aren't those two the same thing? I mean, because if you distributed it, you'd get back to x, y minus x.
Oh.
Yeah. Well, so we're just sort of symbolically doing the same thing. I mean, instead of calling it a and b, we're calling it sine x and cosine x. And then this piece that left over triggered a brain cell. Wait a minute. That looks a lot like pieces that are in that Pythagorean theorem. Let's go try them. And it worked. Now, we actually did an assignment in chapter 4 that was a lot like this. I remember that day. That was the day that Dr. Wells came in and wandered back here. And all of a sudden, I'm trying to teach a class, I have no idea what she's even doing in here. And she's always welcome, I just didn't know what the heck was going on. And on that day, I gave you certain hints about what to do. One of those hints I gave you is, when in doubt, get rid of all the tangent, cosine, tangent, cotangent, secant, cosecant stuff, because that's harder to think about. If we had a problem on the assignment that had something, I'm just going to make a problem up. Let's say tangent of x over cosecant of x, and it said simplify it. Look, I don't know. My brain doesn't really think about tangents and cosecants really all that well, because they're not like the building blocks of all of this. All this stuff is really based on sines and cosines. Let's clean this up a little bit. I mean, if this is the same thing as tangent of x times 1 over cosecant of x, well, tangent is sine over cosine, and cosecant is 1 over sine. Well, now I see sine of x, 1 over cosine of x, they just cancel each other out. And I just get 1 over cosine, which I suppose I could even call secant. And all of a sudden, looking at this, which is ugly, at least, I don't know, maybe cannons break can do that. But I tend to just break it into the pieces. Okay? When in doubt, get rid of those tangents and cosecants and all that kind of stuff. They're hard to think about. The basic building blocks of all this trig stuff is sine and cosine. Get there. Alright, so really that's all that's happening in this tiny little 4-page section here is exercises in doing this. Okay, so for today, you're just doing some exercises with this. Now, hold on. Today's the 6th. Alright. But it's a fair number of problems. Alright. So, this is for Monday. For Monday. This is on page, whatever we're on now. 354. 354. 1 through 6 all. Then 7 to 15 odd. And let's do this. Let's do 21 to 31 odd. There was more, but here's the deal. The more is part of what we'll do on Friday when you guys are out. I think this assignment was getting a little long. So we'll make the rest of that part of what we're doing on Friday that you'll do as part of the making things up. You won't have all that due on Monday because you have other stuff going on by Monday. But I'll set out and come up with a calendar as to when you guys will have to get the rest of that done. But let me just make a note for that here. I'm just going to put over here, I only gave them this part today. They can do the rest for the makeup of your assignment.
Oh, no.
And we'll figure that out. Okay. I bet I know what happened when I set up the invitation. So I did it in blocks where I copied parts of the list one to another. Just out of curiosity, Symphony, did you get the invitation to join this class in Google Classroom?
I didn't.
You did? You know what? I bet I did. I will. I'll just add you.
No, I'm in it.
Yeah,
Oh,
I was saying,
I went to my trash.
I just didn't have an email.
Oh,
I'm
yeah.
already in the class. Though.
You already were in there?
Added all the people.
Oh, so you are in there? though? Like if you bring up the app or something like that, you go to Google
Yes.
Classroom? Okay. I bet what happened is I cut and pasted in blocks, and then it only takes, sometimes Google does that, where it only takes the first, like if you cut and paste a list of addresses, it actually only does the first one. And I'd love to know why the smart engineers at Google sometimes do that. Alright. Anyway, go ahead and start with this here. Because here's the deal. The other thing that makes me stressed out about this for Monday is, remember, that's also the day you have the online stuff about conics. It's about circles in particular. This is that Khan Academy stuff. And I'll send you guys an email so that you have all this in one night, or an email or text or something so you remember. And you have it. Yeah, Natalie. There is, and I'll send it to you guys in just a minute.
Can I go ahead and turn on my camera?
What?
The assignment that went with the
You can, yeah. Yeah. Yeah, if you want the virtual one turned in, that's fine. How hard was it? It was not hard, right? Okay, let me go ahead and stop the camera here.
Or wait,